CLion a cross-platform IDE for C and C++. Download now.
So I'm gonna talk about coroutines. Coroutines are great. You've got some task that you want to do in parallel, and it also needs to do some IO, so you just put that in a coroutine, then you can co-await it, and while the thread, this then suspends the coroutine, and the thread is free to do other stuff in your thread pool. The interesting thing here is the implementation of the submit method in the thread pool. So the problem is that we want to make submit generic, so accept an arbitrarily awaitable, and then someone need to get the coroutine handle out of it. That way we can then take the handle and push that onto the queue that's then consumed by the worker threads. But how do we get the handle out of the awaitable? Right? The only thing we can do with an awaitable is await it, and we don't have a coroutine. So how can we await it? Well, we create a coroutine, right? So we create a lambda. And this lambda is a coroutine. It returns a special coroutine, like a pool task that makes sure that the coroutine is destroyed at the appropriate times and stuff. And then inside the lambda, we can call co-await, because now we're having a coroutine. And we immediately invoke this lambda and get our return object. This is then our task. We can get the handle out of it and push that into the queue. And this is an immediately invoked coroutine lambda. It's an easy way to create a coroutine, and it's also completely and utterly crashes. The reason it crashes is because of the lifetime here. So what's going on is we create the lambda, it stores a copy of the awaitable inside the capture. We then begin the lambda execution because it's immediately invoked. This creates a coroutine, it moves all parameters on the lambda. In this case, it's only the this pointer into the coroutine frame and suspends. The lambda is then destroyed because we continue execution in the caller. We then get the handle, pass that to work push. Eventually, we will start executing that handle in some other thread, resuming the handle, jumping back into the lambda. And this tries to await on the lambda capture, but the lambda has long been destroyed in the other thread. It's really obvious if you look at the lowering. So the compiler creates a lambda that stores the awaitable. Then it has a call operator that takes a pointer to the lambda. We await this. And then, as you can see here, we simply pass the lambda as the local variable by pointer to the call operator. This then the pointer gets copied into the coroutine. And when we later resume it, we crash. Right? So if you've got an immediately invoked coroutine lambda, this just doesn't work. Right? The lifetime isn't correct. So if you have an immediately invoked coroutine lambda, it's destroyed immediately. It must not capture anything. So you have to pass the thing by parameter, because the parameters are copied into the coroutine frame, but not the this pointer. I mean, the this pointer is also copied, but not the actual lambda. So the naive code is actually undefined behavior, because this is C++. And so thankfully, we have the core guidelines that actually say, do not use capturing lambdas that are coroutines, because you run in this issue. But this is unsatisfactory, because if you have multiple parameters, it's just really annoying. You have to put in the types, you have to repeat it, and this is just ugly. Like, captures have the perfect syntax for this, and it's a shame that they don't work. And it would be so easy to make them work, right? All we need to do is, instead of having this lowering, where we pass the lambda by pointer, we need this lowering, where we pass the lambda by value. Because then the lambda is a parameter, it will be passed by value into the coroutine frame, and everything works out nicely. And luckily, since C++23, we're able to get this lowering. We just have to use deducing this. So deducing this, new feature in C++23. Okay. And the magic incantation is this auto in the lambda parameter. So the this auto means capture the this, pass the this by value. And then we get the lowering where we pass the lambda by value. The captures are moved into the coroutine frame, and everything just works. So when you have an immediately invoked coroutine lambda, remember to use this magic notation, this auto, in the argument list. And we can actually make that a bit fancier. So instead of writing this, we write it this way using the lambda invoker. So the lambda invoker is an empty type that has an overloaded error star operator. And the overloaded error star operator, I'm not sure how many actually know what the error star operator normally does, but anyways, in this case, we overload it to mean, please call the lambda immediately. And then we can write the code like this, and this has the nice benefit that we don't have this ugly call at the end. Instead, we've got the lambda invoker and this thing. But the obvious reason we're going to do that is because now we can hide the entire first line in a macro. So we define an async macro that takes the coroutine type and any captures, and then we generate the lambda invoker, the expression, and the thing, and now it actually looks like a language feature. Right? It's like just an async scope that allows us to do things, create the lambda. It's a language feature in many languages, and in C++ we can do it via macro. Macros are great. So immediately invoked coroutine lambdas must capture star this by value, and to do that, you have to use the this auto notation in your coroutine lambda. Otherwise, it will just crash. So remember that. Thank you.